polynomials. So let's start with some simple examples. How would you factor this expression, 6x minus 12? All we can do is take out the GCF, the greatest common factor, which is 6. Now to get what remains, divide. 6x divided by 6 is x, and negative 12 divided by 6 is negative 2. So that's all we could do for this example. Let's try two similar problems. Let's factor 3x cubed minus 9x squared, and also 4x squared minus 12x. So, with the one on the bottom, we need to take out the GCF. We can take out a 4 from 4 and negative 12, and we can also take out an x variable because they both contain it. 4x squared divided by 4x is x. Negative 12x divided by 4x is minus 3. So that's how we can factor that expression. Now for the one above, we can also take out the GCF. In this case, the GCF is going to be 3x squared. We could take out a 3 from 3 and negative 9, and each term has at least two x variables, so we can take out an x squared. Now 3x cubed divided by 3x squared is x. Negative 9x squared divided by 3x squared is minus 3. And so that's it for those two examples. Now the next thing we need to talk about is factoring trinomials. This is when we have three terms, and we're going to factor it when the leading coefficient is 1. So what you want to do is find two numbers that multiply to 12 but add to 7. Two numbers that multiply to 12 but add to 7 are 3 and 4. 3 plus 4 is 7, 3 times 4 is 12. And so the way you would write your answer is going to be like this. It's x plus 3 times x plus 4. And so that's it for that example. Now here's another one. Try this one. X squared plus 2x minus 15. Feel free to pause the video if you want to work on it. So what two numbers multiply to negative 15 but add to 2? We know 5 times 3 is positive 15, but we need to add a negative sign. If we try negative 5 and positive 3, this adds up to negative 2. But if we try positive 5, negative 3, it adds up to positive 2 but still multiplies to negative 15. So the answer is going to be x plus 5 times x minus 3. And so that is how we can factor that expression. Try this one. 2x squared minus 6x minus 56. Now notice that the leading coefficient is not 1, it's 2. So what you want to do first is see if there's a GCF that you can factor. Notice that all of the coefficients are even. So we're going to try factoring out a 2. 2x squared divided by 2 is x squared. Negative 6x divided by 2 is negative 3x. Negative 56 divided by 2 is negative 28. So we now have a trinomial with a leading coefficient of 1. So now let's find two numbers that multiply to negative 28 but add to the middle coefficient of negative 3. Well, we know 7 times 4 is 28. If we try positive 7 and negative 4, that adds up to positive 3. But negative 7 and positive 4 adds up to negative 3. So the answer is going to be 2 times x minus 7 times x plus 4. And so that's it for this example. Now let's try another similar example. Let's factor 3x squared minus 18x plus 24. So feel free to pause the video if you want to try it. Notice that all of the coefficients are divisible by 3. So we're going to take out the GCF, which is 3. 3x squared divided by 3 is x squared. Negative 18x divided by 3 is negative 6x. 24 divided by 3 is 8. So now we need to factor this trinomial on the inside of the parentheses. Two numbers that multiply to 8 but add up to negative 6 are going to be negative 4 and negative 2. Negative 4 plus negative 2 adds up to negative 6. So we can replace x squared minus 6x plus 8 with x minus 4 times x minus 2. And we'll keep the 3 in the front. So this right here is the answer. Now let's say if you have something like this, x squared minus 16 or x squared minus 64. How would you factor these expressions? Go ahead and try these problems. So the situation that we have here is a difference of perfect squares. What you want to do first is take the square root of x squared. The square root of x squared is x. The square root of 16 is 4. And then one of them will be positive and the other will be negative. And that's how you can factor an expression like that. So for the next one, the square root of x squared is x. The square root of 64 is 8. And we're going to have x plus 8, x minus 8. The square root of 4 is 2. The square root of x squared is x. So the square root of 4x squared is 2x. The square root of 25 is 5. And so we're going to have 2x plus 5 and 2x minus 5. For the last one, the square root of 9x squared is 3x. The square root of 49 is 7. And so it's going to be 3x plus 7 times 3x minus 7. So that's how you can factor expressions in the form of a difference of perfect squares. Now let's say if you have a problem that looks like this. 2x squared minus 5x minus 3. What would you do to factor it? Now notice that there's no GCF that we could take out. 2, 5, and 3, there's no common number that we can divide to get rid of the 2 in the front. So in this situation, what we need to do is multiply the leading coefficient by the constant term. 2 times negative 3 is negative 6. Next, find two numbers that multiply to negative 6 but add to the middle coefficient of negative 5. This is going to be negative 6 and plus 1. Negative 6 times 1 is still negative 6, but it adds up to negative 5. Now, what we're going to do now is we're going to replace the middle coefficient with negative 6x plus 1x. Keep in mind the value of the expression is still the same because these two still add up to negative 5x. Now, our next step is something called factoring by grouping. In the first two terms, you want to take out the GCF, which is 2x. 2x squared divided by 2x is x. Negative 6x divided by 2x is minus 3. Now, in the last two terms, take out the GCF. There appears to be none, which in this case, we're going to take out a 1. So when these two things are the same, you're on the right track. So now, we're going to factor out x minus 3. If we take out x minus 3 from this term, we're left with 2x. If we take out x minus 3 from that term, we're left with plus 1. And so the 2x that you see here goes here, and the positive 1 goes there. And so this is the final answer. If you want to check the work, you can FOIL this expression, but it's going to give you what you started with in the beginning. Now let's try a similar example for the sake of practice. Go ahead and factor 6x squared plus x minus 15. So we're going to follow the same procedure. We're going to multiply the leading coefficient by the constant term. 6 times negative 15 is negative 90. Now we need to find two numbers that multiply to negative 90 but add to positive 1. So this is going to be 9 and 10. We're going to use negative 9 and positive 10. Negative 9 plus 10 is 1. Now our next step is to replace positive 1x with negative 9x and positive 10x, and then factor by grouping. In the first two terms, we can take out a 3x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is minus 3. In the last two terms, we can take out a 5. 10x divided by 5 is 2x. Negative 15 divided by 5 is negative 3. So now we're going to factor out 2x minus 3. So in the next step, you could just write it once. And then what you see here is going to go inside of the next parentheses. So that's going to be 3x plus 5. And so that's how you can factor a trinomial where the leading coefficient is not 1 and when you can't take out the GCF in the beginning.